Hello good day viewers, you are welcome once again to Shabes online tutorial. In today's tutorial we are going to learn how to verify that a function is a solution to a given differential equation. If you are new here, consider subscribing to my channel and also follow me on Facebook, TikTok, Instagram at Shabes online tutorial. So the question on the board read: verify that the indicated function is a solution of the given ordinary differential equation. So we have two differential equation here. So the first one we have dy over ds is equal to x y to the power of half, where y is equal to 1 over 16 x to the power of 4. So we're asked to verify that the left hand side is equal to the right hand side. So let's get started. So the left hand side is dy over ds. It implies that we are going to differentiate y once, then we see whether the result of the left hand side is going to be the same as the right hand side. So y is equal to 1 over 16 x to the power of 4. Now at first derivative we have dy over ds is going to be equal to, remember in differentiation this is using power rule. 4 will be multiplied by the coefficient of x, then we take 1 from the power. So in differential equation you need to revise your derivative, the product rule, quotient rule, and the rest rule of differentiation. So 4 multiplied by 1 over 16 is going to give us 4 over 16 x, and this 4 over 16, 4 can go into itself one time, then 4 can go into 16 4 times, so it's equivalent to 1 over 4. Then you take away 1 from the power, which is going to be 3. 1 multiplied by x cubed over 3 is also the same as 1 multiplied by s cubed. It's also the same as s cubed over 4. So, and you notice that this left hand side is not the same as right hand side. But what are we going to do? You check. Remember the value of y is given as 1 over 16 x to the power of 4. So we are going to substitute this value of y to the right hand side. So right hand side of the equation, which is sy to power half. Now we substitute y to this right hand side. It's going to be x, then we open bracket, y is what, 1 over 16 x to the power 4, then raised to the power of half. The half is from the right hand side. So this can be written as, according to law of indices, this power half, the numerator can share this power, and also the denominator can also share this power. So you are going to have s open bracket 1 multiplied by s to the power of 4 is still s to the power of 4. So you are going to have s to the power of 4 raised to the power of half, then over 16 raised to the power of half. So what we just did, we just share this power to the numerator, which is s to the power of 4 raised to the power half, then 16 raised to the power of half. So this is going to give us s open bracket s to the power of 4 raised to the power half. According to law of indices, so we can multiply the power together. Then 4 multiplied by 1 is going to give us 4, and 4 divided by 2 is going to be 2. So it's going to be x to the power of 2 over 16 raised to the power of half is going to give us 4. So this, now we can use this x to open the bracket. X multiplied by x squared is going to give us what? S cubed, then over 4. So this is the right hand side. And we notice that the right hand side and the left hand side, they are equal. Therefore, left hand side of this equation is equal to the right hand side of the equation. Therefore, this y is equal to 1 over 16 s cubed is a solution to this given differential equation. So let us look at number 2. Number 2, we have y prime prime minus 2y prime plus y is equal to 0. And we're giving y to be what? X exponential x. What we are going to do in this form, this differential equation is written in prime notation and y is given. So it's very simple. Y prime prime means second derivative of y. We are going to differentiate this y 2 times, then we substitute to this place. Minus 2 multiplied by, you differentiate y once, then you substitute to this place, then plus y, then you substitute y. Let's see whether the left hand side is going to be equal to the right hand side. The right hand side is 0 and this is the left hand side. So first thing, let us get our ingredient before we substitute to this differential equation. So y is equal to x exponential x. So y prime first derivative will be equal to, remember, x multiplied by exponential x. We are going to use product rule. So you recall your product rule. So the first one is x and this is exponential x. Keep x constant, then multiply by, you differentiate exponential s. The derivative of exponential s is also exponential s. Then plus, you keep exponential s constant, then you differentiate x is going to be 1. The derivative of x is 1. And now we can multiply them together. Y prime will be equal to x multiplied by x exponential s is going to be x exponential s, then plus 1 multiplied by exponential s is going to be exponential x. So this is the first derivative of y. Now we are looking for the second derivative. So y prime prime. To get the second derivative, we are going to differentiate the first derivative of y. Then we keep x, this is product, we are going to use product rule here. So we keep x constant, differentiate exponential s is going to give us exponential s. Derivative of exponential f is still exponential x. Then plus, keep exponential s constant, then you differentiate x is going to be 1. Then plus, this plus is the one from the derivative, the function plus. Then here we have exponential s, and remember, derivative exponential x is still exponential x. So we are going to have exponential x. So y prime prime will be equal to x multiplied by exponential s. It will give us x exponential x, then plus exponential x multiplied by 1 is going to give us exponential x. Then exponential x plus exponential x is going to give us 2 exponential x. Now we have gotten the second derivative and also the first derivative, and y is given from the question. Now we are going to substitute to the left hand side of the equation. Left hand side of this equation, which is equal to what? Y prime prime minus 2 y prime plus y is equal to, this is the left hand side. We are going to check whether it's going to give us the right hand side, which is 0. So y prime prime is what? I'm going to substitute x exponential x plus 2 exponential x, then minus 2, then you open bracket. Y prime, that's y at first derivative, is going to be x exponential x plus exponential x, then plus y, and y from the equation is what? X exponential x. Now we're going to expand this bracket. X exponential x plus 2 exponential s minus 2 multiplied by x exponential s is going to give us 2x exponential x, then minus 2 multiplied by plus exponential s is going to give us minus 2 exponential x, then plus x exponential x. Now we can look at the function very well. So we can combine s exponential x, then 2x exponential x, then we have another s exponential x. So we can combine them together. This is one of the x exponential s and 1. So we can add them together. It's going to be 2x exponential x. Then we have another x exponential x, which is minus 2x exponential x. Now we are done with x exponential s. Then let's go back to exponential s. In this place we have 2 exponential s. This is this place. Then we have another minus exponential x. So that is all. So if you look at this, they are the same, and this is, so sorry, this is 2 2 exponential minus 2, sorry, 2 minus 2 exponential s, 2 exponential x. So if you look at this, they are the same and these are the same. 2s exponential s minus 2s exponential s is going to be 0. Then 2 exponential s minus 2 exponential s, it will also cancel, it will be 0. Therefore, the left hand side is going to be 0, which is equal to the right hand side, which is equal to 0. Therefore, this y as a function is a solution to this given differential equation. Thanks for watching, and please follow me and subscribe